We will go ahead and get started. So welcome, everyone. It's great to have you all with us today. This talk is sponsored by the Yale Center for Environmental Communication at the Yale School of the Environment. As background, the Yale Center for Environmental Communication focuses on 4 main areas. First, we conduct research on public climate change knowledge, risk perceptions, policy support, and behavior, and of course, the psychological, cultural, and political factors that shape them. Second, we teach students and train working professionals around the world in climate communication. Third, we're helping to build a global network of climate communication scientists and and practitioners. And finally, we inform and engage the public through environmental journalism, including Yale Climate Connections, our own climate news service, including a team of reporters writing online stories, a great feature called Eye on the Storm, featuring leading meteorologists covering extreme weather events and climate change in real time, and Climate Connections, our national radio program that broadcasts a new 1.5-minute long story about climate change each day on more than 750 stations nationwide and available as a podcast. So in 2023, the Yale Program on Climate Change Communication launched a partnership with Climate Central, World Weather Attribution, and the Global Strategic Communications Council to inform and inspire climate action by communicating how climate change is affecting extreme weather events and people's daily lives. Frequent, scientifically credible messages linking local extreme weather events to climate change can help support climate change awareness, acceptance, and action. As our planet continues to overheat, it is vital to understand and communicate how human-caused climate change is affecting extreme weather events. We are excited to introduce you today to the field of attribution science and some message experiments that illustrate the value of communicating these links between climate change and extreme weather to the public. For those interested in learning more about how to communicate climate change during this year's danger season, please register for our webinar in partnership with Potential Energy, which is tomorrow, Thursday at 12 o'clock noon Eastern Time, using the link in the chat. So with that, let me introduce today's moderator, Dr. Jennifer Marlon, Senior Research Scientist at the Yale School of the Environment and Director of Data Science for the Yale Program on Climate Change Communication. Jen, over to you.
Hi, and welcome everyone. Thank you so much, Tony. Good afternoon, and welcome to today's webinar on climate science attribution. We are thrilled to have you with us today as we explore the fascinating world of how scientists determine how human activities are influencing specific weather events and broader climate patterns. Climate attribution science is a rapidly advancing field. It helps us understand the links between climate change and extreme weather, and it allows us to better prepare for and mitigate the impacts of climate change on our communities and on our environment. And this is so important. This science that's being conducted now, we're pushing the leading edge here, and it's providing the scientific basis in a quantified way for informed decision-making, for raising public awareness about the problem and the impacts and the solutions. Quantifying the links between climate change and extreme weather can influence laws and litigation. It can change cultural norms through media communication, and it can also lead to increased collaboration and cooperation at the international level. And all of this work, connecting the dots in a quantifiable way, in a scientific manner, enables policymakers, the media, and other stakeholders to work together more efficiently, more effectively, and more meaningfully to address and accelerate our work and efforts on addressing and communicating the impacts of climate change. So today, we are very honored to have 3 distinguished experts with us. Dr. Friederike Otto is a senior lecturer in climate science at the Grantham Institute for Climate Change and the Environment and co-lead of the World Weather Attribution. Freddie is a leading attribution scientist who researches extreme weather events such as droughts, heat waves, and storms, and whether and to what extent these events are made more likely or intense due to climate change. Freddie is the co-lead of World Weather Attribution, which is an international effort to analyze and communicate the possible influence of climate change on extreme events. Through these attribution studies, which provide timely scientific evidence showing the extent to which climate change influenced a given event, the World Weather Attribution has helped to change the global conversation around climate change. And this is influencing adaptation strategies and paving the way for new sustainability litigation. Dr. Andrew Pershing is the Vice President for Science at Climate Central. Andy leads climate science activities at Climate Central, and his role includes bridging primary research and media analysis to amplify critical work on climate change and climate impacts and make it more accessible to audiences and people around the world. As the Director of Attribution Science and Climate Fingerprinting, Andy is developing tools like the Climate Shift Index, which he will present, to quantify how climate changes increase the likelihood or severity of conditions in the atmosphere and the ocean. He works closely with communications experts at Climate Central and other partners to help the media and others to incorporate this information into their own content. And he has deep experience working with journalists to present climate science on air and in print. Finally, Dr. Laura Thomas Walters is a research specialist and deputy director of experimental research at the YPCCC. Laura is an environmental social scientist who applies psychological insights into human behavior to tackle some of conservation's most pressing problems. Her research focuses on the design and evaluation of behavior change interventions, drawing upon multiple disciplines and methodologies, including both qualitative and quantitative approaches. Recently, Laura has led research on the influence of Climate Central's Climate Shift Index, testing messages about the tool and how it affects people's understanding of the connection between climate change and extreme weather in the US, in the UK, and in India. Her research also explores the most effective methods of framing these messages to alter beliefs, boost policy support for climate change action, and enhance communication about extreme weather events. So one final note before we begin our presentations regarding logistics, if you have questions for our panelists, please use the Q&A feature at the bottom of your screen and be aware that you will only see the question that you asked. We have staff monitoring the questions, so be assured we can see your questions, and I will use as many as I can as we have time to answer. And then our most popular question, I'm going to share the answer to it right now, because the most popular question is, will you make a recording of this conversation and will it be available? And the answer is yes, we are recording the conversation. It will be available on our website, and we will send a link to everyone who registered after the webinar. So with that, I would love to hand it over to Freddie.
Thank you very much. And let me start. So as Jen has introduced, I am leading World Weather Attribution, which is an initiative of scientists from across the world, although the core team is based in Europe, to answer the question whether and to what extent human-induced climate change altered the likelihood and intensity of an extreme weather event. So what does that mean? What has become increasingly clear in the last decades, but particularly the last few years, is that we are long in the era of loss and damage, and most extreme weather events that are happening today are happening, at least in part, because of human-induced climate change. So that means they are hotter in terms of heat waves, or they are more intense when it comes to heavy rainfall or droughts. But not all events are changing in the same way, and not all events are changing because of climate change. And so what our work is doing is really trying to find out, for what kind of events is climate change a real game changer? Where does climate change not play a big role? But we also always look into what other things go wrong. So what's the role of vulnerability and exposure in driving the impacts of these extreme weather events? Because of course, if you have an extreme weather event and there are no people, no infrastructure, no ecosystems in its way, then it doesn't lead to any disasters. But of course, the more vulnerable and the more exposed people and ecosystems are, the more extreme in the sense of impacts these events are, even if they might not be actually very extreme from a point of view of the weather event. So for no type of extreme event is the role of climate change stronger and more obvious than for extreme heat events. So just within the last year, we had, for our team, 76 triggered heat waves, and that is our events. We have built a methodology that monitors humanitarian impacts of extreme weather events, and when they reach a particular threshold, then we consider doing a study. And within the last 12 months, 76 of these extreme heat waves has triggered, and we have done 7 studies on these extreme heat events, and you can just see the headline results here on this map. But the main message is that out of these 7, 6 heat waves have been so hot that these temperatures would have been impossible to reach without human-induced climate change. So that means that these extreme heat waves that you see now happening again and again are so hot that they would never have occurred from a statistical point of view without climate change. That doesn't mean there wasn't a heat wave, but it would have been a lot cooler. So how do we know this? The idea behind event attribution, and it's the same idea that also the climate shift index is using, that Andy will introduce in a minute, is quite straightforward. So what we need to do is to find out, first of all, what has happened. So we are interested in this example here on the left-hand side. There was an extreme heat wave in the Philippines earlier this year in April. So first of all, we need to find out what has actually happened. And we found that, okay, over a period of about 15 days, temperatures were above 32 degrees over the Philippines, and that was the period when the impacts were worse. And so we use that as the characterization of this heat wave. And then to do an attribution study, the first thing to do is to find out what kind of event is that in today's climate. So is it a 1 in 10-year event? Is it a 1 in 100-year event? And to do that, we use weather observations and climate models and simulate what are possible extreme, or what are possible April temperatures over these 15-day period in the world we live in today. So with 1.2 degrees of global warming that we already have. And then we get something like you can see on the right-hand side in this red curve. So we get a likelihood of a distribution of different temperatures that are possible. And then also we find out how likely the event that we have experienced in today's climate is. And we find that in today's climate, that's about a 1 in 10-year event. So that means in any given year, there's a 10% chance of such an event to occur. Then to find out what the role of climate change is, we do the same thing again, but in the world as it might have been without climate change. And because we know very well how many greenhouse gases have been put into the atmosphere since the beginning of the Industrial Revolution, we can do this, and we can actually remove these greenhouse gases from the atmosphere of climate models, of weather models, of statistical models, and then simulate what are possible temperatures over 15 days in April in the Philippines in the world that would have been without climate change. And in this case, we get this blue curve that you can see here, where we see that actually the temperatures that have been observed are not part of this distribution. And that means these events, exactly as it occurred with the temperatures as hot as they were, would not have been possible without climate change. And this is why when you look on the very right-hand side at the bottom, where you have these pink dots, in the middle is the event in today's climate, the 1 in 10-year event, and on the left-hand side is the event that it would have been without climate change, and you don't see any pink dots. So these events just don't happen. And then we can, of course, do the same thing also, not just by removing greenhouse gases due to burning of fossil fuels from the atmosphere of climate models, but we can also add more and see, okay, what will happen if we don't stop burning fossil fuels pretty quickly and reach a 2-degree world. And then we see that this event would be a 1 in 2-year event. So basically in any year you have a 50% chance of such a heat wave to occur. A different way to look at the same type, a different way to look at this is to say, okay, this event that we are interested in is a 1 in 10-year event, and in this climate, in today's climate, the 1 in 10-year event is a bit above 32 degrees Celsius. So how hot would the 1 in 10-year event be in the world without climate change? And this is what you can see on the left-hand side at the top with these burning embers, or however you want to call them, that the 1 in 10-year event would only be a bit over 31 degrees without in the world without climate change. So this is looking at the intensity of the event and how that has changed due to climate change. So in the middle, you see an example for a different type of heat wave that happened at the same time. So you can see that while for heat waves, the message is always the same. Climate change is an absolute game changer, but the exact numbers change depending on which region of the world you look at and which heat wave. So this is the method, and the method works not just for heat waves, but of course for all sorts of other extreme weather events as well. So for example, for heavy precipitation, and here are just some examples of heavy rainfall events that we have looked at. And I don't want to go into too much detail on this, but because the method is exactly the same. But the main thing here to say is that while with heat waves, climate change is usually making them orders of magnitude, or 100 times or 200 times or even more likely, whereas for flood events there are some some events where climate change does actually not play a big role. So the second one you can see here is that high vulnerability, and also the IOD, which is the Indian Ocean dipole, so just a natural pattern of ocean temperatures played a big role, whereas all the others had actually an increase because of climate change, but it's usually smaller than we see for heat waves. Before I finish, the most important thing I find, and usually in these studies, is actually not the number of how much more climate change made this event more likely or less likely in the case of cold waves, for example, but what else has happened and how much does preparedness and vulnerability change, whether these extreme events, and especially when they become much more likely, turn into disasters. And I don't want to go into detail of this, but of course there are many factors that play a big role. Whether early warning systems, did these early warning systems actually reach people? Did they reach the most vulnerable? Where did people live? If they live in informal housing, of course they have much fewer opportunities to go to safety in terms of a flash flood. And all these factors play a hugely important role. So just to give one example of a storm that affected Greece and Libya last September, the same storm killed 17 people in Greece and led to quite a lot of infrastructure failures. But in Libya, more than 4,000 people lost their lives because of these. The storm was exactly the same, but because of the much different vulnerabilities and the inexistence of early warning systems and the mismanagement of, for example, the dams that were supposed to support this, to protect the city from flooding. And again, we can do this for droughts as well. Droughts are a bit more complicated because you don't have to just look at one variable like temperature or rainfall, but there's usually a combination of different variables that are important. The lack of rainfall, but then also if temperatures are high, that leads to more evaporation, usually exacerbating the drought. And we can use the same methods also to look at the different components and then see overall how climate change affects these events. So I will end here because we will have a whole talk on the communication of it and hand over to Andy. But yeah, that was a very quick introduction, and happy to answer questions later.
All right. It is always very exciting to follow Freddie, in part because we're really building on the work that that Freddie and World Weather Attribution have done. So I'm going to talk about some of the tools that we're putting together for how to think about and understand this hot summer that we're facing. So It used to be that we were all taught, back in the day that, no single weather event can be linked to climate change. This was the pervasive narrative. This was the talking point that anybody working in sort of the weather-climate interface was given. But, the work that Freddie highlighted, so back in 2004, the first study of linking a particular weather event to climate change happened 20 years ago. World Weather Attribution launched in 2015. 2016, we have the National Academy of Sciences study that comes out that kind of gives a seal of approval on attribution, and especially on the rapid attribution approaches that the World Weather Attribution and folks like us are using. What I think, the reason I like to highlight this is I think we really have shifted the narrative, right? It's no longer that no single event can be linked to climate change. It really is that climate change is an important factor in many weather events. And it's really just a question of, can we quantify that and how strong is that influence? So as Freddie mentioned, we have sort of different levels of attributability. There are things in the world that are easy, and there are things in the world that are hard. According to the IPCC, they phrase this in terms of the trends, kind of global trends and global patterns. So temperature is easy, right? Heat waves are occurring more frequently around the globe. So that's a very strong trend that can be linked to climate change. Wildfires, there are trends as well, but it's always less clear with a complicated process like wildfires on the left. When it comes to specific weather events, like the kind that Freddie mentioned, you get things start to really spread apart. So temperature, heat waves, much easier than things like precipitation events, hurricanes, and wildfire. It's not that we can't do it, and Freddie gave some great examples, but it takes a lot more work. And that's why at Climate Central, we have focused on temperature, because it is in many ways connected to these other events. But it is also easy enough that we could actually put together a system that can give us these attribution calculations every day, everywhere. So our system is called the Climate Shift Index, and we'll put the links in the chat, but it's csi.climatecentral.org. On the website, you'll be able to see a global map. So here I've zoomed in on the United States, and I selected today. And so this is the temperature anomaly map. So the red colors are showing you places that are warmer than normal, where normal is defined relative to the recent 30-year average, so 1991 through 2020. So that normal period already includes about 0.8 degrees Celsius of global warming. But relative to that normal, you can see that today in the US, it is hot in the West, basically a band stretching from California to Wisconsin, and you could continue it up into Quebec and Labrador. And then we have a cool area on the eastern part of the country, and Mexico and the Caribbean have also been warm. So then we come in and we do the same calculations that World Weather Attribution does, but we do them on the fly using the global forecast models. And so we're able to then put a metric on top of those temperature anomalies and say that for many of the temperatures that we're seeing, we're able to quantify that climate change has influenced those temperatures. So the dark red color here in sort of the Four Corners region, down into Mexico, also in Cuba, that means that those temperatures are at least 5 times more likely in a world that has human-caused climate change than they would be in a world without human-caused global warming. And then you can see that the region of influence where we say that there's a detectable climate fingerprint spreads up into the upper Midwest. And then we have a break in Ontario, and then it kind of resumes as we move on. And we get different levels of attributability where we're able to kind of isolate this signal changes from place to place. We always have stronger attributability in warmer areas. So like Cuba and Mexico, it takes a smaller temperature anomaly to get to level 5. And then we have periods of the year where it can be very challenging. So we tend to get weaker responses in the upper Midwest and the Great Plains during the summer because the observed warming trends have been weaker in that region. So the evidence of climate influence is weaker during the summer in those locations. So that's as of today, we have the Climate Shift Index, which can give us information on daily air temperature. We have a paper that just came out about a month ago on ocean temperature. And so we're actually going to be bringing out an ocean temperature version of the climate shift index within a couple of weeks. So we're targeting mid-July. And I'm an oceanographer. I really care about the ocean. I want to use this to be able to talk about the human influence on things like coral bleaching, on fisheries, on things like that. But the reason we've developed it at Climate Central is because it gives us a pathway to talking about the climate links with hurricanes. So just to show you what that will look like. So this is the track line of Hurricane Ian, which went across Florida in 2022. Again, this is the anomaly. So pink means warmer than normal, blue means cooler than normal. You can see that in that year in 2022, basically the ocean in this part of the world was warmer than normal just about everywhere. And then we bring in our attribution calculations. And so you can see there's a lot of red area, there's a lot of yellow, there's almost no gray at all on the map. But this is a scale that is very different than what we've been looking at for air temperature. So these blue areas are places where the hurricane went through rapid intensification, where the ocean temperature caused it to blow up and become a much bigger, much more powerful storm. And we are able to say that the water that Hurricane Ian passed over, those water temperatures are 100 times more likely because of climate change. Again, we see when we look at the ocean, much stronger levels of attributability. We really see, many cases that there are temperatures that just could not have existed in the past. So how are we using this material? Well, one of the things we're doing is putting out regular reports and analyses on particular kinds of time periods. So we're doing seasonal reports. We did a Heat Action Day report in collaboration with World Weather Attribution and International Red Cross Red Crescent. And we have a report coming out in a couple of weeks on nighttime heat. And what we're really doing with this system is trying to go from the perspective of what does it mean to live on a planet that is at about 1.3, 1.4 degrees Celsius above normal, right? Nobody actually experiences that global temperature. We experience weather. And so how has that experience changed throughout the year and place to place around the world? We also are producing heat alerts. You can think of these as quick hit versions of the kinds of reports that World Weather Attribution puts together, but we are trying to do this in advance. So using a 3-day forecast. So we just released 2 yesterday, highlighting the extreme heat in the southwest part of the US, and also extreme heat in the eastern part of the Mediterranean and the Middle East. So seen in both of these places, unusually warm conditions that have a very strong and quantifiable climate fingerprint. So we will put these links in the chat, but you can see a few of them. We have a global map where you can go and look at the climate shift index every day, and you can go back a couple of months, and we will be adding more of the past data as well. And you can also look ahead 2 days. We have our reports and heat alerts posted on our website. World Weather Attribution has a wonderful reporting guide for journalists, as well as great explainer material on attribution science and how to talk about it. Climate Central, we produce a weekly package of materials that we call Climate Matters. It's a free bulletin that you can sign up for. And then we have various mailing lists that you can sign up for as well. So thank you for your attention, and I will turn it over to Laura.
Thanks, Andy. Let me just get my screen up. Right. So as you've heard, there's lots of super clever people doing really hard science stuff, which, we super need. But we also want normal people to understand this as well. And I'm counting myself in the normal, non-meteorologist, climate science person. We want to understand, how do we communicate that science, communicate the fact that climate change is affecting extreme weather to everybody, because it affects everybody and it's really important we know that. We know from lots and lots of previous research all about communicating climate change is it's really important that we try and make it concrete and we make it local. So, enough of the starving polar bears on an ice floe over there. We want to be picturing, the impacts that are happening to people in their local neighborhoods right now. And unfortunately, extreme weather is a perfect example of that. As Freddie and Andy have been talking about, climate change is making a lot of really horrible extreme weather events more and more likely and making them worse. And this is happening all over the world. People are right now dying because of the effects of climate change on extreme weather. So again, unfortunately, this is a perfect case to try and communicate these things and get people concerned about climate change. So at Yale, at YPCCC, we've been working on a series of experiments trying to look at, well, what's the best messages we can use to try and communicate these links? I'll talk about one of our recent experiments that we just completed, where we looked at 3 different countries, the UK, the US, and India. I can tell you a little bit about the baseline beliefs. So in some good news for change, most people do already believe that climate change made extreme weather in 2023 either a lot or extremely more likely, 65% of people. And that was quite a bit higher in India than in the UK, but still, and the US, but still in both America and the UK, the majority of people do already believe that climate change is having an impact, making extreme weather a lot or extremely likely. And the reason why it's higher in India, I think, is because these beliefs increase if people have either personally experienced extreme weather. So if they've personally experienced an extreme weather event like a heat wave or flood in the last 2 years, they're even more likely to think that climate change is having an impact. Or if they hear about it in the media frequently, like at least on a weekly basis. And as you can see in India, a lot more people report having experienced extreme weather event in the last 2 years. 79% of people do, compared to 45 and 39%, which is still quite a lot in the US and the UK. And in India, they're also much more likely to report hearing about extreme weather events in the media more frequently. 42% hear about it on a daily basis, which is quite a lot. But still, a lot of people in all 3 countries are hearing about this in the media already. So we wanted to test a couple of different things. One, we wanted to know whether people would react differently to information about heat waves versus floods. So if you say scientists say that climate change is making heat waves at least 3 times more likely, or is making floods at least 3 times more likely, do people respond differently to those different bits of information, and particularly in different countries? Like we thought, I don't know, maybe in the UK, for example, people are quite concerned about floods, but heat waves are often treated as, yay, summer's finally here, which isn't quite the right attitude. So we want to see whether people would take this information seriously. And we also wanted to look at the way that we actually frame those numbers. So Climate Central often or generally use times more likely in terms of the way they frame it. So they've got the scale from 1 to 5, and this heat was made at least 5 times more likely or 3 times more likely. But some previous research suggests that people might respond better to percentages, basically, I think, because they're just bigger numbers. So we also want to test whether people would respond better if we said 200% more likely instead of 3 times more likely. And this is the type of message that we showed people, and a lot of people, about 3,500 people in each country, so over 10,000 people total. So we have an introductory paragraph about the impact of extreme weather events, and then at the bottom is our treatment, the sentence in bold, where we say, scientists say climate change made either heat waves or floods at least either 3 times or 200% more likely. And then we also have an unrelated message that's just about cheetahs, because cheetahs are fun, so we can compare responses. And then we also did something different. We had an active control. And what I mean by that is we had the paragraph about extreme weather events, but we didn't include anything about climate change at all. So we reminded people that extreme weather events are bad, they're having these impacts. We don't mention climate change in any way, to see how people respond to that sort of message also. What we were concerned about, what we're really trying to change is the belief that climate change is having an impact on extreme weather events. So whether people do attribute the likelihood of floods and heat waves and things like that to to climate change. So we're looking at it both generally, but also we asked about specific types of extreme weather. So do they think that climate change is making flooding more likely, or is making heat waves more likely? And we also asked about severity. So we only talked about the likelihood, but we measured whether people thought they were also climate change is making extreme weather worse as well. So some more good news. All treatments do work. So however we framed it, after reading our messages, everybody, all the treatments did increase the belief that climate change is making extreme weather in 2023 more likely. So that is good news, I think. Something that's really interesting is that the active control also increased that belief. So if you remember, that's a message that doesn't mention climate change at all. We just talk about extreme weather. And we don't know for sure, but my suspicion there is that the media is beginning to link it to climate change. Thanks to the really good work of Andy and Freddie, the media now knows of this impact. It's talking about this impact more. And so we think maybe our messages just prompt that. So they read about we remind them about extreme weather events, and then they remember reading about how climate change is having an impact. So, we want that message to still be out there. We found overall, and in each country, no single way of framing it had a bigger impact than another. So people respond as well to heat waves and floods. And there's also a crossover effect. So if you tell someone climate change is making flooding more likely, they extrapolate from that, and they're then likely to believe that climate change is making heat waves more likely as well, and vice versa. So people seem to correlate all these different events in their mind when you talk about it. And there's no overall effect of, if you say times versus percentage. Though if you held a gun to my head and you said, you have to give me one way to frame it, I would probably lean towards percentages, because we've seen they have performed well in previous studies. And although it's not significant, it's getting close. But overall, times or it's a small difference, and both work really well. So in summary, people are already concerned about climate change and extreme weather. They think there's a link there already, most people. And just talking about extreme weather is good. But blaming climate change is even better. So, we need people to keep talking about the extreme weather events that are happening, and we need them to link it to climate change. And however you do that, all the framings we've tried so far, all of them have worked. And we've tried quite a few. We've tried time framings, we've tried adding explanations, we've done lots of stuff. And so far, everything does have a positive impact. So yeah, I think that was all pretty good news. I'll hand back over to Jen now.
Thank you so much, Laura, and thank you to all our speakers. So I would like to kick off the questions. We have many coming in, and I want to just start building on what you just said, Laura, actually, that blaming climate change is even better, but I would love to hear from all of you in your own experience, in your own words, why it's so important to focus on this. We understand that people are connecting the dots. 65% in the US, for example, are saying climate change is affecting the weather. But why invest so much on understanding the cause? Because there is some question as to whether that's productive in a communication context. Some people don't want to know about the causes, maybe, or it increases polarization in the US at least. But obviously you're devoting a lot of time and effort, and a lot of people feel strongly about attribution. But why is it so important to focus on attribution and the causes, the causal connection here? And anyone can chime in, or let's start off with Freddie.
Okay, I think the reason why it's so important is to do that for not just for extreme weather in a very general way, but for very specific events, is because it connects people's experience with the relatively abstract signs of climate change, and I think that just brings that just gives a very different level of understanding what climate change actually means. And I also think when we see who is impacted by these extreme weather events most strongly, and how they impact people, and the main thing is they very seriously, through the increase in extreme weather event, climate change is massively violating human rights that we in the West have actually been very proud of implementing over the last 70 years, but happily violate by burning fossil fuels. And I think by connecting that these through burning fossil fuels, we make these floods much heavier, we make these heat waves much heavier, and that means people lose their lives. People have a right to life. People lose their houses. People have a right to housing. People have a right to family and to have a safe place to be. And that, I think, is important if we at some point want to do something about climate change. We need to change, to go away from this. That is something that is some extra problem that doesn't affect us, and that's something that has to do with polar bears or is something in the far future, but that it's actually here and now violating the human rights of the vast majority of the global population.
Andy, thank you,
Yeah,
Freddie.
I think it's a great question. And it's one that we think about basically every day, right? I think we are kind of asking ourselves a question of like, what's the value of this work? The big one, and we actually have some analysis of this, is that attribution allows you to make the direct connection between a weather event that people experienced and didn't like and human-caused climate change. And I think the human causality is really critical. You see that in the Yale maps, that's one of the big gaps in the United States, and it's one of the big gaps around the world. And so attribution goes right at that. And so by being able to put these studies out in the world, you see the narrative change, and you see the discussion of the event shift from being, oh my gosh, it's hot, how unusually hot is it, to this is a climate change event. The impacts of your experience are related to human-caused climate change, and that's something that we actually see happening in the media directly related to the attribution work the World of Attribution and Climate Central are doing. I think the other thing, and Freddie kind of alluded to this in her presentation, and I think in some ways these are some of the most important studies that World Weather Attribution has done, are the few that don't conclude that climate change was a major driver, right? So by doing the attribution science, sometimes the answer is, actually kind of an ordinary sort of event that could have existed. And then the reason it was a disaster was on us in another way, right? It was other choices that humans made that amplified the risk and turned it into a disaster. And it points you to a different set of solutions than when you're looking at climate change.
And what about from a communication standpoint?
Yeah, I mean, yes, it mentioned all the really good stuff about, well, we should care because people are dying and everything. But also in terms of communicating, like we said at the beginning, there's been a bit of a tradition of messaging around climate change, environmental stuff being very much about starving polar bears, which is sad, but it's not especially motivating for like ordinary normal people who are busy like trying to pay their rent and feed their kids instead of worrying about polar bears. I was talking about extreme weather events that are happening, right here in the country. The year before last in England, Wales, like nearly 3,000 people died in that heat wave. That's unfortunately a lot more motivating and a lot closer to home. That's the type of messaging that makes people take action.
So can we talk a little bit and move into hazard specific questions, because there is a lot of interest in knowing what events are we more certain about, what events are we less certain about, and a few questions that are coming in are specifically about flooding. It would be great to hear can you just clearly explain the connection between climate change and flooding? And rainfall, but also wildfires. What can we say about wildfires? And or tornadoes? And what are the kinds of events that we, are there any kinds of events that we don't have any evidence that climate change is affecting them? Maybe you can speak a little bit to the diversity of impacts and how attribution science is related to those different events.
Don't know. Do you want me to maybe I start and then Andy can add? So I think in terms of heat waves is very clear, very strong. But for flooding, we have a very strong physical understanding of how climate change impacts flooding resulting from short-term rainfall, so on the hours to up to 5 days, because that's it's called the Clausius-Clapeyron relationship, and that means that a warmer atmosphere can hold more water vapor. That water vapor gets out of the atmosphere as heavy rainfall, and so with about 1 degree of warming leads to about a 7% increase in heavy rainfall on these short timescales. So flooding that is affected by is caused by heavy rainfall events on these timescales has a very strong connection, of course. But then there's a second way of how climate change can affect rainfall, and that is because we have changed the composition of the atmosphere, because we have changed the temperature distribution of the atmosphere. That means we have changed weather patterns, so where weather systems develop and how they move. And so you can have that, while for each individual storm you have more rainfall, you actually have fewer storms coming into a particular region or in a particular season. So that means that overall, if you look at the whole month or the whole season, you might see no change in the rainfall overall, or you might even see a decrease because you actually don't get these rainfall systems. And because the second effect is very different depending on the region and the season, we do see different effects on flooding across the world, and how well we understand them really depends on how well we understand and how good we can measure these parts of the world. So because the climate science, as all science, has traditionally been done very much in the West, we have lots of data, lots of models that have been developed in the UK, in the US, in Europe, but a lot fewer observations, a lot fewer studies for parts of the global South. So that's where a big discrepancy in our understanding comes. And then for droughts, it really depends on which aspect of the drought is relevant, because if it's really the lack of rainfall that causes the problems, then it's the same problem that is just different from different parts of the world, depending on how the weather systems have changed. But if also the availability of water in the soil, so for agriculture and ecosystems, that's a big part, is relevant, then you actually usually do see almost everywhere an increase in drought risk, because you have the high temperature and the temperature increase everywhere. And that's similar to wildfires. While of course wildfires are very complex, and also the weather conditions, which is obviously the part of the wildfire that we look at in attribution, is quite complex. It depends on high temperatures, it depends on low humidity, high wind speeds, and then also low rainfall in the month leading up to the fires. But if none of these things change, what changes everywhere is that the risk of high temperatures is going up, and that is actually what we see throughout the globe, that almost everywhere we do see an increase in wildfire risk, which is mostly driven by this increase in temperature. And I'll let Andy talk about tornadoes.
Great. So tornadoes are really tough because the data, I mean, they're just... One way to think about attribution science is that if you average anything over the planet, it's 100% attributable. We can say, we can absolutely use the cause when we're talking about global mean temperatures. Humans cause global mean temperatures to be as warm as they are. As you move to small and smaller parts of the planet, it gets harder because you have all of the noise of weather coming into play. And tornadoes are really, really small, right? They're not represented in climate models, and they're not well sampled in our data. You just think about like, radar is the main tool. That really has only been around for 30 years, kind of in sort of the application in at least, and only in the United States, for that amount of time. So tornadoes are really tough, but we think there are some things that you can do, because tornadoes and other kinds of severe weather do require a certain amount of heat. They don't happen, right? This is why they happen in the Midwest and the Great Plains in the US in the spring and in the summer, because you have so much heat around, and that's the energy that drives the storms. So some of the tornadoes that we've seen lately, like there were some outbreaks in Kentucky a couple of years ago, some tornadoes that are occurring out of season. You can often look and say that, man, the air temperature was really warm. The air temperature has a quantifiable climate fingerprint. This is a time of year that it wouldn't occur. And so you can start to build a case there. It's not going to be as strongly quantitative as what we can do for a heat wave, but you can start to put together the evidence that says that that climate change was having an influence on these events. And then you asked, I think the question was also, what can't we attribute? I'd love to actually say a few things that I expect are obvious to most people, but they are questions that we get. Climate change does not influence earthquakes, it does not influence volcanoes, and it does not influence geomagnetic solar storms like the big Northern Lights things we had a couple of weeks ago. Those things are happening in a different domain. Climate change is really about the weather, right? Wind, water, ocean, and ice.
Thank you. So given all this complexity, let me turn to communication again for you, Laura. We would love to hear, we have a question about the most effective way to connect people's lived experiences, their everyday lives with the changing climate at the personal or community level. And then I'm going to kind of pair that with a follow-up question, which is a bit more simple. Just how can we talk about this attribution science in a way that will be clear and resonate with most normal people, as you referred to, the non-experts here?
Yeah, so I mean, I think this is an excellent opportunity to do more local work and more targeted messaging. So when there is a heat wave happening in a specific area, that's an opportunity to talk to the people there who are currently experiencing it. And people remain concerned for quite a while afterwards. We did a messaging experiment talking about the July 2023 heat wave that affected a lot of America. People were still concerned and responded to our messages 3 or 4 months later. And we're doing research on that now as well, about how we can use targeted Facebook ads at the time of extreme weather events. So that's one thing I think is, could be really, really promising. But of course, it needs to be always paired with hope. I think there might have been a few questions about that. Extreme weather, I mean, a hurricane or flood, that feels way out of our power to do anything about. But, we do all have power. We have power in a lot of different domains, from behavioral, from, deciding to eat less meat, because that's a huge contributor to climate change, to political, contacting our representatives, to collective action, getting together and making changes in our community. I think it's really important that all the messages around climate change is affecting extreme weather right now, people are, being killed because of it right now, has to be combined with those messages of hope and ideas of how people can make change. You need to empower people at the same time.
Yeah, that's so important. It's challenging. We talk about the 6 Americas at the YPCCC, how we have a range of attitudes, from people who are very engaged and alarmed and maybe even anxious about the problem, all the way to the other side of the spectrum, people who are dismissive and don't believe that the Earth is warming. Only 11% are truly dismissive. And what people don't realize is 57% are either alarmed, meaning they believe it's an urgent problem, they support aggressive action, or concerned, meaning they think it's a serious problem, maybe not super urgent, but important. So 57% in the US. And yet, so we're thinking about this broad spectrum of people. Are there, what do you recommend given this diversity, Laura?
Well, so one bit of encouraging news is that we did look with all the experiments that we've just done on talking about climate change and extreme weather. We looked at subgroups, so we looked at the people who are, cautious or are dismissive, and our messages did work for every single group of people. Our messages did move. In fact, probably the biggest effect we had on the people who are cautious, who aren't quite sure whether or not climate change is like really happening, if it's really human caused or not. But probably the biggest effect of those, and across a political spectrum as well. Our messages work for Republicans as well as Democrats. So talking about climate change and extreme weather, it works, for everybody, and we see like pretty much no backlash. We see no one going the other way in reaction to the messages either. So it looks like this could be a really good area to try and talk to people, across the polarization about. But more generally, I think it's really important that we appeal to people's values. And that's why it's really important that we all start talking to our own social networks, and that we do, encourage everybody to break this culture of silence, to talk to each other, because I think you'll find that people are a lot more concerned about climate change than you realize. Lots of people think that no one else really cares, and it's not true. Actually, lots and lots of people do really care across the political spectrum. Like you said, the outright deniers are actually a very small percentage. They might be loud, but they're not many. So start talking to people and appeal to the values that they care about. And extreme weather might be a really good topic for that, particularly in Britain, because every conversation starts with complaining about the weather.
And so just a couple minutes here left. I want to just get all of your thoughts, if we have time, about what your findings in this work are indicating about sort of the current projections from the IPCC and our state of the science. And so also where are we headed? What advances can we expect next? What's your sense about what's coming in the near future here? Both in terms of aligning your work with the current science. Some people are wondering if are the current IPCC estimates too conservative? Do you have insight about that? But maybe more broadly, just what are you working on? What can we expect to see in terms of attribution science and the related challenges going forward in the next year or so? Maybe Andy, do you want to start?
So just really quickly, we're bringing out ocean temperature attribution. We hope to be able to say more about hurricanes, if not this year, then next year. And I'm really interested in impacts, because that's how people are ultimately experiencing it. What can we do to really understand and make that connection to the things that are actually impacting people's lives back to the global warming problem?
Maybe I can answer the IPCC question, given that I've been an author on a lot of the last IPCC report. So I mean, the IPCC is conservative in the sense that the IPCC doesn't do any new research. The IPCC assesses all the research that has been published in sort of the decade leading up to the report. And so of course, if there are discrepancies, or if there are studies that say, on certain topics, maybe there's high uncertainty, then there is nothing else that the IPCC can do than say there's high uncertainty. And that's particularly true for the parts where there is no research or no data. And that means that the IPCC can say, we don't know, and we have very, very little knowledge, which of course means that the messages that come out are limited to the things where we have a lot of research on. And it is accurately reflecting the research. So there's nothing that gets kicked under the table or so on, but of course it only reflects the research that's out there. And in this, especially in the field of attribution and extreme weather, since the last publication of the IPCC report, which was in the science part was in 2001, and the cutoff of publication was a year before, so in not 2001, 2021, sorry, was in 2020, which is in this field that only really exists for the last 10 years, is a huge amount of time. So there's a lot that has happened since. And I think we see in terms of weather events, we see exactly what the projections have been for the last decades. What has changed is the knowledge about vulnerability. So we have realized since that was a major sort of advancement in the last IPCC report, that actually our societies are much more vulnerable than we originally thought to even relatively small changes in the weather. So the projections were right, but it hurts much more than anyone has expected.
All right, well, we are at time. So first of all, thank you, Dr. Marlon, for moderating this fascinating conversation, and to Freddie, Andy, and Laura for such thoughtful insights and all of the research that you continue to do to help us understand the links between climate change and extreme weather. We will send everyone an email shortly with a link to the recording. And reminder, please join us and our partners Potential Energy tomorrow at 12 o'clock Eastern Time for more insights on how to communicate about extreme weather and climate change. You can register using the link in the chat. And then please join us on September 6th for a discussion with Yale's own Dr. Laurie Santos on how to maintain mental health and resilience amidst the climate crisis. Should be a fascinating conversation. So thanks again, and we look forward to seeing you soon.